Okay, so since we're just about time to start, the first problem is just a quick review problem of one of the word problems that we had last time, a mixture problem. So just going to give you a couple minutes to sort through that. You got a test the next time we're together. There's going to be a mixture problem on the test, I promise. So this is an opportunity to work through another one. If you're watching on the video, I am going to pause this so you do the same thing while you work the problem. All right, so there's a couple different ways you can set this problem up. The particular way that you get the information out of the problem is not super important to me. It's that you get the information and you set up the two equations. So what I did in class is I just drew boxes because I like to draw boxes for some reason. And so I'm just going to represent each of these parts of the mixture. So we're going to add two things together. We're going to get a final result. And this is how I like to display that. Again, this is not the required part of the problem. If you display it in a different way, that is perfectly fine. I know we all kind of think about things a little bit differently. So now I'm going to fill in, and if you have any questions about where I'm getting this information from, that would be awesome. Just raise your hand. Let me know what I need to explain better. I want to be helpful. So we got our candy store managers planning to mix some $2 per pound nuts. So this is $2 per pound that I'm going to fill in on my first box, with some $1 per pound chocolate. Okay, I guess we're keeping the numbers nice and round on this problem. And wants to obtain 100 pounds of a mixture that will sell for $1.30. Okay, so this is going to be $1.30. Whoops, there we go. So we're going to set up our two equations using this tool right here. So I don't know how much of the $2 per pound. I don't know how much of the $1 per pound chocolate. But I do know that I want 100 pounds, pardon me, 100 pounds at the end. So that gives me my first equation. The total equation is x plus y. However much of the first thing plus however much of the second thing I add together has to add up to 100. So there's equation 1. So however you got it, you should have that equation somewhere on your page. That's good to look at. And then the second equation is going to be the cost that I have. So if I have X pounds of these nuts right here, then that $2 for each pound, that's going to be 2x is the total cost of that. If the chocolate's $1 per pound, and for each pound, that's going to be 1y, or just plain old y. And then 100 times $1.30 means the total amount I have invested in this mixture is 100 times $1.30, which will end up being $130 when I pop that into the calculator. So that's going to give me my second equation. So first equation is the total amount of stuff. The second equation on this one is the cost. And so that is 2x plus 1y is equal to 130. So just so that the review is full, let's go ahead and solve this. I'm going to eliminate the y's because I think that will be the quickest and cleanest thing to do. So I'm just going to multiply this top equation by -1. You could also multiply the bottom equation by -1 instead. If you eliminated the x's, the easiest thing to do would be eliminate the top, to multiply the top equation by -2. Okay, there's lots of options you have when solving these things. You could also substitute. You could solve for x or y in one of the equations and substitute. So there's no limitations there. If I just say solve, you can solve any way you want. Now on the test, I do have a problem that I ask you to use substitution. I do have a problem that I ask you to use elimination, and then I have other problems that you can just solve however you want. Okay, so whatever tool in your tool bag you like best. So when I do this, the top equation becomes -x minus y is -100. The next equation stays the same. I'm not doing anything to it. Now I add those things together, and I have -x plus 2x, that's x. The y's cancel, that's the whole purpose of the elimination method. And then -100 plus 130 is 30. So what that tells me is the amount of the nut mixture that I'm putting into this is 30 pounds. And then the way I get the other thing is I know that x plus y is 100, so that's going to tell me y has to be 70 pounds. Just for space sake, I'm not going to, well, I guess I will because I want you to, so I don't want you to skimp on me. So we'll just state the answer here, and the answer is that we are going to add 30 pounds of nuts and 70 pounds of chocolate. And there we go. We're done with the problem. I know mixture problems are tough. That's why we did one to review. So that's going to pop up on this next test. It's also going to pop up on the final exam. So just spoilers, there's a mixture problem on the final exam. So put an asterisk by that. That's something to keep in your back pocket as you're getting ready for those things. Okay, so today's topic for section 4. I know I passed out 2 sheets and there's 2 sections and you're freaking out, but this used to be actually in the old version of the book, just used to be 1 section. The scientific notation, the second section won't take us very long at all. So I know it seems like a lot, but it won't end up being a lot. Okay, so what I want to do first for you, because again, I know probably you've had algebra a bunch of times in your life in the past, but I just don't want to assume anything. So I want to make sure we're all on the same page as far as exponents. So where we're going to start is just with a quick review of the rules of exponents. If you need a deeper review of these 4 properties that are on this page, talk to me after class, okay? And we can set something up and make sure you get what you need. But I think you'll be able to catch on from our quick review. So the first thing is what's called the product rule. The product rule talks about if you multiply 2 things together. So when I multiply 2 things that have the same base, for instance, like x to the 7th times x to the 4th. So it's called the product rule because I'm multiplying these 2 things together. And who can tell me, who remembers what you do with the exponents? Yeah, what's up? Yeah, add them, exactly. In the product rule, when you're multiplying things with the same base, you add the exponents. So my base, notice this, okay? Again, this is a common mistake that even people familiar with these rules make. The base is going to stay the same, okay? So it's x here, it's going to stay x. And then to take care of the multiplication, I add the exponents. So 7 plus 4 is 11. So I have x to the 11th power. So I have 5 examples that I'm going to write down for you to do, and it give you the opportunity to ask whatever questions that you need to clarify what's going on. So here are 5 problems for you to just mop up real quick. So the first one is this. I've got y to the 3rd times y to the 9th times y to the 6th. Then the next one is, I'm just going to come down here, 8 to the 4th times 8 to the 3rd. Want to know what that is? Then I have x times x to the 7th. The next one is p to the 5th times q squared. And then last but not least, I've got to come down here because I'm not managing my space very well. I apologize, you deserve better. And then I've got a squared b to the 5th, and then times a to the 3rd, b to the 6th. So I'm going to give you a couple of minutes to go through. Take your time. Make sure you're processing and understanding this. Which one? That's a q. P to the 5th times q to the 2nd. Each of these problems has a point that I'm trying to make. Okay, so if you encounter a difficulty, just chill, and maybe you'll get the point that I'm trying to make on the problem. All right, let's try this out. The first one, my intent here is, this is just a straightforward product rule problem, just so that you're getting your hands dirty doing this. So when I have y to the 3rd times y to the 9th times y to the 6th, what's the base of my answer going to be? Y. And what's the exponent going to be? Yep, 3 plus 9 is 12. 12 plus 6 is 18. So I have y to the 18th power. So far, so good? All right, the next one, the purpose of the next one is I just want to make sure we're comfortable when the base is a number. So I've got 8 to the 4th times 8 to the 3rd. Again, the bases are the same, so I can apply the product rule. What's the base of my answer going to be? 8. Yes, the base does not change when you apply the product rule. So a common misconception. So if you made this is an opportunity to circle, draw an arrow, learn from this. The base is not 64. Okay, the product rule takes care of multiplying the things together. So 4 plus 3 is 8 to the 7th power. If you pop that into your calculator, that's fine, but I'm not into that. It's too big of a number. We use exponents to summarize things. That's the tool. Okay, the next one, x times x to the 7th. The reason I'm giving this problem is what's the exponent on the first x? 1. Even though it's not written, there is a 1 assumed there. Okay, so if you didn't know that, just pencil it in. And so that's going to give me x to the 1 plus 7 or 8. The next problem, p to the 5th, q to the 2nd. Are the bases the same on this? Does the product rule apply? No, because the bases are not the same, there's nothing I can do. That is as simplified as I can make it. P to the 5th times q to the 2nd. Sorry if you got hung up on that one. I just want to make sure you're clear that for the product rule to apply, you have to have the same base. Don't oversimplify and call that something to the 7th power, because it's not. Last one, I just wanted to see, we've got 2 bases here, all being multiplied together, so no big deal. So I've got a's. How many a's do I have here? 2 plus 3 is 5. And then b's. How many b's do I have? 5 plus 6 is 11. Again, those bases there are not the same, so don't oversimplify. You are done with that problem. All right, the product rule. That's our quick review of that. Anybody got anything they need further clarification on with the product rule? All right, the next rule of exponents is called the quotient rule. Quotient means divide. So what do I do when I divide? So for instance, my example is going to be something like x to the 9th divided by x to the 5th. Well, again, I'm hoping that this is review. Does anyone know what we do when we divide the bases here? You subtract the exponent. Well said. Thank you very much. And so again, the base does not change. Don't divide that out and give me 1. Okay, the quotient rule takes care of that. So my base stays x. And then 9 minus 5 is 4. So here's 3 problems for you. Again, just to make sure that we are brushing up on this. So here's your first one, t to the 8th divided by t to the 2nd. Then 3 to the 17th divided by 3 to the 5th. And finally, x to the 7th, y to the 5th divided by x, y to the 3rd. Go ahead and simplify each of those using the quotient rule. All right, the first problem, t to the 8th divided by t to the 2nd. What's the base on my answer? T, again, the base does not change. And then what is my power on the answer? 8 minus 2 gives me 6. Okay, we doing okay? All right, 3 to the 17th divided by 3 to the 5th. Once again, what's the base of the answer? Okay, 3. And then 17 minus 5 is 3 to the 12th. It's going to be a very large number. I wouldn't invest the ink in writing down all those digits. It's good like that. And then last but not least, again, just like with multiplying, make sure that you keep each base in its own lane. So I've got x's. So I'm going to have x to the 7 minus 1 or 6. And then y to the 5 minus 3 or 2. And there's my quick review of the quotient rule. Anything uncomfortable about the quotient rule? Now we're going to circle back because the quotient rule is going to provide our introduction to today's new material, or with a supposed new material. For some of you, you'll have seen it. Others, it will be new for you. Okay, but we'll get there in a minute. The third big rule of exponents is called the power rule. It means what happens when I have a power like x to the 7th, and then I'm raising that directly to another power. Okay, so it's power to a power. Again, in this situation, anybody remember what you do with the exponents when you have a power raised directly to another power? You multiply, yes. So that's x to the 7 times 3, or going to be 21st. Great. So again, here's just a couple problems for you to take a gander at. Hoping I do have a point with a couple of these problems for you. So the first one is x raised to the 5th power raised to the 6th, nice and straightforward. The next one is 3x squared y to the 3rd, then raised to the 4th power. And then the third problem I have for you is 2x squared over y to the 8th, and that's all raised to the 3rd power. In fact, do me this favor, just do the first two for now. We'll do the third one in just a moment, because there might be something I have to clarify with regards to the second and third problem. All right, so the first one, I just asked you to do the first two of the three. I'll give you a little more time to do the third one after we talk about the second one. So the first one, very straightforward problem. I've got x raised to the 5th, raised to the 6th. So what's the final result there? X to the 30th, fantastic. X to the 30th power, love that, great job. All right, the next one. All right, talk me through. What's my answer look like for this problem right here? Okay, I'm going to agree with 2/3 of that. 3, the x to the 8th, the y to the 12th. The x and the y are perfect. And this is why I asked you to stop after this second one, because I want to make sure we clear up this misconception right here. What's the power on the 3 as it stands right now? A 1. So please do not forget that you also have to raise that 3 to the 4th power. Okay, that is a very common mistake. I was expecting that. So don't forget that that first term, 3 to the 1 times 4, is going to be 3 to the 4th. Now, if you want to use your calculator, you can say that's 81 if you want. I don't require that on the tests. I don't read your instructions in my math lab. I don't know one way or the other if my math lab, if it takes it both ways or you have to multiply it out. Okay, so with that said, since we've gotten over that hurdle, go ahead and do the third problem now. Write any wrongs that you made on the previous one. Remember, it's okay to make mistakes. I was fully expecting that. All right, so help me out. What's the power on the 2 for this problem? Perfect, appreciate that. 2 to the 3rd, great. Or you can say it's 8, that's fine too. Then I have x to the 2 times 3 or 6th power, and then y to the 8 times 3 or 24th power. Now again, like I said, on the test I give you, that is perfect. You don't have to do another thing, but you can. 2 to the 3rd, 2 times 2 is 8. X to the 6th, y to the 24th. Those mean the same thing. I am impartial. I don't care which one you write down. One other thing I want to just state about I don't even know what rule. One other thing I want to state about the power rule. Okay, another misconception is if I have something like this, let's say I have x squared plus y to the 3rd raised to the 4th power. The power rule does not apply to that situation. Can anyone tell me why the power rule does not apply right there? Yes, perfect. Well said. Thank you very much. because this is addition. Okay, you would have to do something completely different. So do not, I know you want to, we all want to, but avoid this. Do not distribute this for, this is not equal to, okay, big fat not equals. This is not equal to x to the 8th plus y to the 12th. That is so super wrong, okay? So if you would not have done that, then don't, but I find that, again, like the other thing, that's just something, a habit we've developed that I wanna make sure that we address. Okay, so just shining a little light on a common mistake. So that is not equal to, do not do that when there's a plus or a minus in the parentheses. Okay, the last of the basic properties of exponents is the zero exponent property. This is super fun. And so what this says right here is if I have a number like 7 and I'm raising it to the 0 power, okay, what is 7 to the 0 power? It is equal to 1, okay, not 0. You're not multiplying the 7 times the 0. It's 7 to the 0 power. If you don't know why that is, here's why that is. Remember, math is all about patterns. So let's just do this. 7 to the 3rd power is kind of a large number, but I wanted to be able to follow the pattern. So let me grab my calculator because I'm not that smart. It's 343. 7 to the 2nd power is 49. 7 to the 1st power is 7. So then that begs the question, what's 7 to the 0? Well, look at the pattern. What do we do as we're going down the ladder? What do we do each time to the number to get to the next rung on the ladder? To get from 343 to 49, we do what? Divide by 7, yes. To get from 49 to 7, we do what? Divide by 7. So the pattern would remain that to get from here to here, I'm going to do the same thing. I'm going to divide by 7, and that's why 7 to the 0 power is 1. Okay. So I'm never going to try to trick you. The only time this would not apply is for 0. 0 to the 0 power is an indeterminate form. There's mathematicians that'll tell you that's 0. There's mathematicians that'll tell you that's 1, because you can prove it either way. I'm not going to trick you. All I want you to remember is anything I ask you that's going to be raised to the 0 power is always going to be 1. So here's your one problem that you're going to do. If I give you this, negative 12,342.76 to the 0 power, okay, write down what the answer to that is. And everyone confidently wrote down, what is it? 1. Thank you very much. I appreciate that. Okay, one more thing I just want to mention, just to make sure I'm being thorough before we turn the page and we do kind of the extension of this. That's the new part. Sometimes students come in and they have calculators. They don't know how to use the calculators to do powers. So this is my calculator. I got the TI-30. There's 2 types of buttons you're going to have to do powers. The TI-30X here that I have has a caret on it. Okay, right where my finger is, that caret. That caret is your power. So for instance, one of our answers was 8 to the 7th. So if you want to do that, you're going to hit the number 8, then you hit the caret, and then you hit 7, and then you hit the enter, and it turns out to be a very large number. Now, I don't have an example of that calculator. If somebody does and wants to give it to me so I can show you, there's other calculators that have this button right here. Some other TIs and pretty much the Casios, if you have a Casio, will have a button that looks like this. It'll be y to the x power. It functions in the exact same capacity. It's just a different button. So if you wanted to do 8 to the 7th with that, you would hit the number 8, and then you'd hit the y to the x button, and then you'd hit the 7. So you've just told the calculator what the base is, and then you've told it it's an exponent problem, what the 7 is, and then you hit enter, and it's going to give you the result. Okay, those are the 2 buttons that are most common on the calculators that you can use in this class. Okay, so if you're looking at your calculator, or when you get home, if you don't know how to do powers, well, you can Google it, but you can also bring it to class, and I'll be happy to show you. It's pretty easy to figure out. Okay. All right, so that's our quick review of powers. Now we're going to flip to the next page. So we're going to talk about the idea now. If you noticed, everything we did on the review part of this page was all positive exponents. And so the thing that we're going to talk about is what happens if our exponents are negative. So I'm going to take the problem, the first problem we did in the quotient rule, and I'm just going to reverse it. Instead of having x to the 9th over x to the 5th, I'm going to have x to the 5th divided by x to the 9th. And we're going to do this two ways so that you can hopefully see, if you've never seen before, what a negative exponent is communicating to you. All right, so if we apply the quotient rule just straight like we just did, the quotient rule says subtract your exponents. So that is x to the, what's 5 minus 9? -4. Great job, everybody. I appreciate this. So again, in case you're not sure, you don't remember what a negative in your exponent means, let me just do this another way so that you can see. I'm just gonna write out these things. So x to the 5th in the top means I have 5 x's. So I'm going to do that. 3, 4, 5. That's fun. And then x to the 9th in the bottom means I'm going to have 9 of them. So a little tedious. Sorry that you have to watch me write the letter x 9 times. Hopefully I'm counting well in my head. I think I did that just fine. There you go. Now when I cancel, I have 5 x's in the top. I can cancel with 5 x's in the bottom. So I'm going to go ahead and do that. So 1, and then 2, and then 3, and 4, and 5. So here's the result. How many x's do I have left? And where are those 4 x's? That's what the negative exponent is telling you, is that the result of this is you have 4 x's in the denominator. So the thing that I just want to remind you, in case you've not seen this before, or in case it's been a while for you, when you have a negative exponent, a negative in your exponent is a position. Okay? It's not telling you the value is negative. It's telling you the position of the base. And it's telling you the base is in the wrong place. So what you're going to do, this is simplifying. This is a required step. When you see a negative exponent in your answer, then you're going to say, okay, x to the -4, that's 1 over x to the +4. Okay, I have to make that change. So what I have to lead off right here is I just have a few problems to practice converting from a negative exponent to a positive. Okay, so that's the only thing for these problems. And so I've got several because I think it's a fun place to start. So go ahead and simplify each of these. Y to the -6, 5 to the -2, 3 times p to the -2. Be careful on that one. 1 over y to the -7, and then a to the -3 over b to the -2. Okay, so give each of those a try at simplifying, and simplifying means you're getting rid of the negative exponents. All right, the intent of the first two problems is just to be straightforward introduction to the negative exponents. So if you've done a problem and your answer is y to the -6, then how are you going to rewrite that answer? It's going to be what?
1 over y6.
Beautiful. 1 over y to the +6. Notice when I put the base where it belongs, I changed the exponent from negative to positive. Okay, it's 1 over y to the +6. We doing okay? Anybody got a concern that they need to bring up while we're going through this? All right, 5 to the -2. So that, again, another straightforward one. 5 to the -2 is what?
1 over 5.
Yeah, 1 over 5 to the 2nd. Now, again, I'm comfortable if you leave it that way, but if you really like to multiply things out, it's 1 over 25. Notice it's not -25. It's not 1 over -25. Okay, the negative exponent does not affect the sign of your result. All right, the next one, the reason I gave this is I just wanted to remind everybody what the exponent is applying to. So I've got 3p to the -2. What is that -2 applying to? Just the p. Okay, so this problem here is different than if I had written 3p in parentheses to the -2. Okay, those are different things. So in this one, the 3 is going to stay where it is. So I'm going to leave the 3 in the top. And then the p to the -2 is what goes to the denominator and becomes p to the second. If I had used parentheses around it like this, then you would bring the whole thing. You'd have 1 over 3p to the second, and then you would say that's 9p squared from there. But I'm running out of room, so I'm just going to leave it where it is. So please note the difference that will occur in your homework. It'll occur on the test. Each thing has its own exponent. In this case, the 3 has an exponent of a 1. All right, the reason I gave the next problem is maybe you didn't know. Again, opportunity to learn. This case, I have a negative exponent in the denominator. What do you think is going to happen to that? Yeah, I'm going to bring the y to the 7th now to the numerator. Okay, so since the y to the -7th was in the denominator, this is going to be y to the +7 in the numerator. Remember, your negative exponent is just telling you the base is in the wrong place. So if you have a negative exponent downstairs, you bring it upstairs. If you have a negative exponent upstairs, you put it downstairs. Okay, either way. And that was the purpose of this follow-up problem, the last one. Both the numerator and the denominator have a negative exponent. So where's the a to the -3rd going to go? Down. So it's going to become a to the +3 downstairs. And where's the b to the -2 going to go? Up. And it's going to be b to the +2. Excellent. All right. So now that's the new material. Okay. So for a bunch of you, that's new. That's why we're here. For some of you, that's review. Okay. Now what we're just going to do is I've got problems that involve the 3 properties of exponents like we just talked about. But now sometimes the exponents are negative. Doesn't change anything else about what you do. Product rule, you still add the exponents. Quotient rule, you still subtract the exponents. Power rule, you still multiply the exponents. Nothing changes. Okay, just some of the numbers are now negative. So we're just going to go one problem at a time. We're going to take this slow. I want you to ask any questions. Make sure you're interacting with me because I don't want you to leave here bothered or upset at me. I want you to have a great rest of your day. And so go ahead and do this first exercise right here. X to the -8 times x to the 4th times x to the 6th. I'm going to give you 30 seconds to make some headway on that. All right, first thing I'm going to do is just notice this is a product rule problem. I'm multiplying these things. And you told me on the previous page that when we multiply the bases, we add the exponents. So my answer is going to be x to the, what do I get when I add -8 plus 4 plus 6? The result is what? X to the 2nd. Okay. Don't be afraid to use your calculators if you need them. That's why we allow calculators in here so that you don't get stressed out about numbers and arithmetic. All right, so if you feel good about that, then let's move to the right and do the next one. Y to the 5th times y to the -9th, please. Again, it's another product rule problem. So I'm gonna when I multiply my bases, I'm gonna add the exponents. So my base stays y. And what do I get when I add 5 and -9? That becomes y to the -4th. Great. Okay, before I move on, you're not quite done. We don't leave negative exponents negative. We're going to simplify that. And so y to the -4th now becomes what? Beautiful. Well said. Thank you very much. 1 over y to the 4th. If you're comfortable with that, then let's do the next one. If not, then please ask a question. Questions are not impositions, okay? They're great moments.
Well, remember last one with the y negative 9. We always just put the y in the numerator to make it positive.
Yes, since this was a product rule problem, both of these y's are already in the numerator. So my answer is in the numerator. That's why I have a y to the negative 4th here. Then after I've done the problem, that's when I say, okay, what is that negative exponent telling me now? Okay, so just do one thing at a time. Do the product rule first. It keeps the y is going to be in the same position the y was over here, which is there's no denominator to this problem. And then that's when I say, okay, now the y's got to be in the bottom. Does that make sense? Yeah. Okay, great question. I appreciate you asking it. Just like, so when you're doing these problems, when you apply the quotient rule, okay, your quotient rule gives you something in the numerator. Okay, now I know you're going to do a few of these and some of you are going to develop shortcuts in your thinking, and that's totally, totally fine. That's learning and that's great. Okay, but I'm going to go through all the steps. Okay, so just know that. So if you've seen this before and you're like, oh, I already know that there's going to be 5 more k's in the bottom than there were at the top, that's fine. You can take shortcuts when you get to that point that you're comfortable doing it. But for now, since I'm assuming at least a lot of you are seeing this for the first time, okay, I'm going to apply the quotient rule. And the quotient rule says my result is going to be a k. And then 7 minus 12 in your calculator, 7 minus 12 is negative 5, which agrees with what we see, right? We see that there's more k's in the denominator than the numerator. So we were expecting that to be negative. So that becomes 1 over k to the 5th power. All right, if you haven't done it already, go ahead and do the next one. Yeah, what's the question? You always simplify negative exponents into positive as your final answer. Yes, that is to take this from k to the negative 5th to 1 over k to the 5th is a required step. On the test, it will be a partial deduction. Okay, I'll give you partial credit for getting this part right and doing the quotient rule. That's great, but then you won't get full credit because you didn't simplify. Okay. All right, so this next one, some students like to do this different than I do. And again, that's totally fine. So if you are a student who's done this before and you like to resolve the negative exponents before doing anything else, that is a perfectly legitimate and wonderful way to do the problem. I'm just going to go ahead and use the rule straight as I've given to you. So I'm going to use the quotient rule. So I'm going to have my x. And I'm going to write this one down since I'm subtracting negatives, and I know sometimes that gets confounding, and that's the purpose to the problem. So my power in the numerator is negative 8. Then I'm subtracting because of the quotient rule. Then my power in the denominator is negative 5. So I have negative 8 minus negative 5. And when you subtract a negative, that's negative 8 plus 5, which becomes negative 3, which is 1 over x to the 3rd. That should be your final answer. Okay, so I know negative exponents sometimes goof with us a little bit, so that's why I've got a couple other problems involving them. So go ahead now in the next row, do the 5 to the 4th divided by 5 to the negative 3rd, please. What's your question? I'm doing the problem as it's set up as a quotient. Quotient rule says you subtract your exponents. Okay, so I take the numerator, negative 8, and I'm going to subtract the denominator, negative 5. So when I subtract a negative number, though, that becomes -8 plus 5. So let me write that off to the side in case that step eluded you. So what I did then is that's -8, then a negative. When I subtract a negative, that becomes plus. Okay, that's not related. That's not the product rule. That's just because we're subtracting a negative number. Okay, that's what happened there. All right, so the same thing happens on the next problem. So I have 5 to the 4th in the top, 5 to the -3rd. Again, it's a quotient rule because it's set up as a division. So my result is going to have a base of 5. Again, I'm going to write this out because I don't want to lose anybody on this. So my power in the numerator is 4. The quotient rule tells me I'm supposed to subtract. And then the power in the denominator is -3. So I'll write this step out this time because I don't want to inadvertently cause any confusion. So when I subtract a negative, that becomes 4 plus 3, and 4 plus 3 is 5 to the 7th. One more quotient rule problem involving a negative exponent. Do the a to the -3rd divided by a to the 6th power. So once again, the quotient rule says I'm going to subtract. So that's a is my base. And then I have -3 is the power in the top, minus 6 is the power in the bottom. So -3 minus 6. Well, we're not subtracting a negative this time. We're just subtracting +6. So I have -3 minus 6 is -9. And I get 1 over a to the 9th power as the final result. Next couple problems are examples of the power rule. So remember, when you have a power raised directly to a power, you multiply. Okay, so do the next problem, which is 2 to the -3rd raised to the -5th. All right, so the power rule says when you have a power raised to a power, you multiply. So again, my base is 2, and then -3 times -5. A negative times a negative is a +15. So I have 2 to the 15th power is the answer to that one. The next problem is just like what we did on the front, on the review part, only with some negative exponents. So give the next one a try. 5x to the 4th, y to the -3rd, and all of that is raised to the -2 power. All right, so be careful on this one, just like we were on the front. Remember, the 5 has an exponent of 1 on it. So if you left the 5 out of this, okay, go back and correct that. So I've got 5, which is going to be raised to the -2 power. Then I'm going to have x raised to the 4 times -2 or -8 power. And then I'm going to have y raised to the -3 times -2 or +6 power. Now what I'm going to do is I'm just going to draw a fraction bar because I see that I've got some negatives and I've got some positives, so I'm going to have to move stuff around. So first, the 5 to the negative 2, is that going to be in the numerator or the denominator? Yep, the negative exponent says move it down, so 5 to the second, or 25 if you prefer. How about the x to the negative 8th? Is that going to be in the numerator or the denominator? That's going to be in the denominator. It's going to be x to the 8th. Fantastic. And then the y to the 6th, is that going to be in the numerator or denominator? It's going to stay right where it is. The exponent's already positive. No need to move it anywhere. And there's my result. Similar problem on the next row. You've got x divided by 2 in parentheses, all raised to the negative 4th power. So give that one a go. So this one, both the x and the 2 in the parentheses have a power of 1. That's what we assumed when there's no exponent on something. It's assumed to be a 1. So what this turns out to be straight away is in the numerator, I've got x to the negative 4th, because 1 times negative 4 will be negative 4. And then in the denominator, it's 2 to the negative 4th for the same reason. 1 times negative 4 is negative 4. So last step, I've got to resolve those negative exponents. So the x to the negative 4th, where am I going to put that? Denominator becomes x to the 4th. And then the 2 to the negative 4th that's in the denominator, what is that going to become? It's going to go in the numerator, and it's going to become 2 to the 4th, or 16 if you prefer. So I'll write or 16 over x to the 4th is another acceptable thing to write. Again, another very similar style problem is right next door. The 6y to the negative 2 over y to the 5th, all of that raised to the negative 4th. You might say, hey, Perkster, should I do the quotient first or should I do the power rule first? And the answer is it absolutely does not matter. If you want to do the same thing as me, I'm going to do the power rule first. I'm going to get rid of the parentheses, and then we'll do the quotient rule. But again, if you already did the problem and you did that in the reverse, we'll all end up in the same place. So I'm going to raise each of these things to the negative 4th power, as I already mentioned to you. So again, don't forget the 6. That's the most common mistake. Honestly, students do great on the exponent problems on the test, with the exception of sometimes forgetting when there's a whole number to raise that to the power as well. So just be super careful. That's why I've been stressing it. So we've got 6 that is going to be raised to the negative 4th power. And then I have a y to the negative 2 raised to the negative 4. Negative 2 times negative 4 is positive 8. And then y to the 5 raised to the negative 4, that's negative 20. So I'll wait on the 6 to the negative 4th. I'm going to now do the quotient rule on the y's. So I have y to the 8th divided by y to the negative 20. And in your calculator, 8 minus negative 20 is the same thing as 8 plus 20, or going to be 28. And then last but not least, I do have that negative exponent to resolve. So the 6 to the negative 4th goes to the bottom. I don't know what 6 to the 4th is. I don't care what it is. I'm going to leave it just 6 to the 4th. And then the y to the 28th is going to stay up top because its exponent is positive. All right, we're getting close to the finish line of this section. Just 2 more exponent problems to do. The next one is just a pair of quotient rule problems all in one. So go ahead and simplify x to the 5th, y to the negative 2 in the numerator. divided by x to the 8th, y to the negative 3 in the denominator. I'm just going to do the two quotient rule problems. Remember, when I see quotients, I'm going to subtract exponents. So for my x's, that's 5 minus 8. 5 minus 8 is negative 3, which agrees with what my eyes are telling me. I've got more x's in the denominator than the numerator. And then I have y to the negative 2 minus negative 3. I'll write that one out because it involves negative exponents. So negative 2 minus negative 3. So when I have negative 2 minus negative 3, that's negative 2 plus 3, or 1. And that gives me this final result. The y is going to stay where it is. The x to the negative 3 goes to the bottom and becomes x to the third. All right, the last problem for us on this page, we're going to do this one step at a time because I know this looks gross, okay, but it's really not as bad as all that if we just take it one thing at a time. So here's what I want you to do. I'm going to give you 20 or 30 seconds to do this. Apply the power rule like we did in the problem just above it. Okay, so just apply the power rule to each of these and then stop. You don't have to do anything else. We'll take this one step at a time. All right, so first thing I asked you to do, just go ahead and apply the power rule. Get rid of these parentheses first thing. So what I have here in the first parentheses is I have 2 raised to the third power, or you can call that 8. I'm just going to leave it to the third for now. Then I have x raised to the 2 raised to the 3. So 2 times 3 is x to the 6. And then y, 2 raised to the 3. 2 times 3 is y to the 6. And then the second set of parentheses, I have this stuff raised to the negative 2. So I have 5 raised to the negative 2 power. And then I have x, negative 2 raised to the negative 2. Negative 2 times negative 2 is x to the 4th. And in the denominator, I have y to the 4 raised to the negative 2. 4 times negative 2 is negative 8. So far, so good. So next step, don't worry about the 2 and the 5 just yet. They have different bases, so there's not anything I can do. We'll deal with what to do there when I get to the negative exponent step. Here's what I would like you to do next is when I multiply fractions, you just multiply tops and bottoms. And so what that means is in the top, I have these x's to multiply. So apply the product rule there. And in the bottoms, I have y's to multiply. So apply the product rule there and then stop. And then we'll finish the problem up. All right, so I told you not to worry about the 2 to the third and 5 to the negative second right now. So I'm just going to write the 2 to the third and then the 5 to the negative second. What I did say to focus on is in the numerator and denominator, I've got some multiplying to do because we're multiplying these fractions. So x to the 6th times x to the 4th, When I multiply those, I get x to what power? Okay, 6 plus 4 is indeed 10. And in the denominator, I have y to the 6th and y to the negative 8th. When I multiply those, I have y to what power? Negative 2, indeed, there you go. So then the very last thing for this problem, and then you'll be done with it, is you have stuff that has negative exponents and stuff with positive exponents. Put everything where it belongs. All right, so the 2 to the 3rd, that already has a positive exponent. It's not going anywhere. And like I've said many times, you can leave that 2 to the 3rd. You can say 2 times 2 times 2 is 8. Does not matter at all. The 5 to the negative 2, that has a negative exponent, so it's going to go to the bottom. So it's 5 to the 2nd or 25. Again, either way you want to write it, I don't care. X to the 10th stays in the top because it has a positive exponent. And then the y to the negative 2, that has a negative exponent. It's in the bottom, so I'm going to move it to the top, and it's going to become y to the 2nd. And there is our introduction to negative exponents. So you'll have a bunch of homework problems to do for that. So you'll be able to do those in the next couple days.